Welcome to Amity Algebra Academy. In today's video, the objective is that after watching this video, students will be able to simplify complex fractions using two methods. Complex fractions are not complex. You will agree after you watch this video.
Remember the good old days of non-complex fractions? To add and subtract fractions, the key was to find a common denominator to be able to work with the fractions. Now just to refresh your memory, 1/3 plus 2/5 equals x. The common denominator would be 15 because the least common multiple of 3 and 5 is 15. Now what you want to do is to multiply each term by a form of 1. For 1/3 you will multiply 5 over 5, and for 2/5 you will want to multiply 3 over 3. And then you will get 5 over 15 plus 6 over 15, and your answer would be 11 over 15. Now we'll get to the complex part. A complex fraction is a fraction where there are multiple denominators or fractions within the fraction. It's fraction inception. So there are two ways to simplify complex fractions. Your main goal is to create a single fraction. We'll start with an example to go over those two methods. This is a complex fraction because the fraction 1 over 2x is in the numerator. 2x is called the minor denominator because 3 is the denominator of the fraction as a whole. 2x is the denominator of the fraction in the numerator. Minor denominator is the denominator of a fraction within the numerator, or a denominator of a fraction. We'll start with method 1. Method 1 is to multiply by a form of 1 using the least common multiple of the minor denominators. There is only one minor denominator right over here. We already said that the minor denominator is 2x, so the LCM of the minor denominator is 2x. Now we will multiply by a form of 1 using the least common multiple. When you are simplifying, you are always allowed to multiply by a form of 1. For example, with 8 over 8, because it does not change the value of the expression, because 1 is the multiplicative identity. In this case, the form of 1 we will use is 2x over 2x. We will cancel out our minor denominator of 2x. The numerator will be 2x over 2x, which can be simplified into 1. The denominator will be 6x. So this fraction simplifies into 1 over 6x. It is no longer complex. Now we'll try out method number 2. Method 2 is to create a single fraction in the numerator and denominator and multiplying by the reciprocal of the denominator. This example already has a single fraction in both the numerator and the denominator. So all there is to do is to multiply by the reciprocal of the fraction. 3 is a whole number, but remember that if we write it as a fraction, it's 3 over 1. You can look at this as dividing the two fractions. 1 over 2x divided by 3 over 1. When we divide by fractions, we multiply by the reciprocal of the denominator. So we would have 1 over 2x times 1 over 3. Doing so, you would get 1 for the numerator and 6x for the denominator. We get the same answer as what we got from method number 1, which is 1 over 6x.
This is a complex fraction because there are minor denominators within the fraction. There are 2 this time instead of 1 from the first example. The minor denominators are 2x and 3x. Method 1. Find the least common multiple of the minor denominators. The least common multiple of 2x and 3x is 6x. We want to cancel out the minor denominators. Remember, you want to multiply by a form of 1 so you wouldn't change the value of the expression. Therefore, we will use 6x over 6x to cancel out the minor denominators. Multiply 1 over 2x by 6x and 6 over 3x by 6x also. This should give you 6x over 2x all over 36x over 3x. Now, reduce both the numerator and denominator, and the original expression will look like this. 3 over 12, and that can be further simplified to 1/4. That is your answer. Method 2. In this example, method 2 does not have too many steps because the fractions in both the numerator and denominator are single fractions. They only have one term each. You can look at this problem as 1 over 2x divided by 6 over 3x. We multiply by the reciprocal to get the simplified fraction. The reciprocal in this case is 3x over 6. So we multiply 1 over 2x by 3x over 6. This gives us 3x over 12x, which again simplifies to 1/4. Again, notice we got the same answer as method 1. This example is a little trickier because there are multiple terms in the numerator and denominator. We will simplify this
using both methods 1 and 2. So for method 1, we multiply by a form of 1 using the lowest common multiple of the minor denominators. In this case, the minor denominators are x and x squared. The lowest common multiple of x and x squared is x squared. So we multiply the whole expression by x squared over x squared, which is a form of 1. After we get to this step, we can distribute the x squared. From here, we can factor out the x from the numerator and take the difference of squares in the denominator. X minus 4 and x minus 4 in the numerator and denominator, we can cancel those out, and we end with x over x plus 2. Method 2 of this one is a little different from the previous examples. There are multiple terms in the numerator and denominator. To make a single fraction, the numerator and denominator, you have to make a common denominator of the both terms separately in the numerator and the denominator. So you can multiply the numerator and denominator of the complex fraction by separate forms of 1. This is okay to do because even though you're multiplying the top and bottom by different forms of 1, it's still a form of 1 and therefore will not change the value of the expression. You can treat this like our first example. You are just finding a common denominator to carry out the operation of subtraction. The LCM of the minor denominators in the fraction in the numerator is x over x. So multiply the terms by x over x to get a common denominator. X over x minus 4 over x is now simplified to get x minus 4 over x. Do the same thing for the fraction in the denominator, multiplying the terms by x squared over x squared and simplifying to get x squared minus 16 over x squared. Now, the both fractions in the numerator and denominator have a single minor denominator. We can multiply by the reciprocal of the denominator. So, x minus 4 over x multiplied by x squared over x squared minus 16. This gives us x squared over x minus 4 over x times x squared minus 16. For the last step, factor. We factor out x minus 4 and x. The final expression would look like this. We learned a lot today, and now let's summarize. First, you learned that the main goal is to simplify a complex fraction to a single fraction by canceling the minor denominators. You can use two methods. Method 1 is to multiply by a form of 1 using the LCM of the minor denominators. Method 2 is to create a single fraction in the numerator and denominator, then multiply by the reciprocal of the denominator. As you get more comfortable, you may see that one method works better for certain problems than the other one. Method 2 will work well when the numerator and denominator have very different minor denominators, while method 1 works better when the least common multiple of minor denominators is easy to work with.
Now that you've become familiar with simplifying complex fractions, here's a hard question for you to try. Keep in mind that this fraction is really advanced, so don't be discouraged if you don't get it right away. Pause the video if you want to try it. There will be an answer and explanation in the end. This example may look very confusing at first glance because there's a lot happening in the denominator. The trick for complex fraction problems where the fraction has many parts is to break it up, trying to consolidate it as much as possible by multiplying by factors of 1. This is a form of method 2. So let's work our way up. First, make a common denominator of the lowest minor denominator. So x minus 1 over x. Now you can multiply by the reciprocal of this part of the denominator to get x over x minus 1. Now completely simplify the denominator with method 2 to get x minus x plus 1 all over x minus 1. You can now factor the numerator's minor denominator. Finally, multiply by the reciprocal of the denominator and simplify to get 1 over x plus 1. How did you do?
Happy mathing! Thanks for watching!